Since our researchers first started putting slide to rule, pioneering theories and applications have found their way from College Station to every corner of the globe. A&M research doesn't stay in a lab. It gets unleashed, helping mankind do things once only imagined, and to do those things faster, safer, and cheaper. It's called A&iMplementation. Today, researchers at Texas A&M, the Texas A&M Transportation Institute, and the Texas A&M Engineering Experiment Station are concentrating on transportation technology. Hang on to your pocket protectors. It's an eye-opening, mind-expanding ride. Texas A&M is bringing world-class talent to the campus through A&M's Institute for Advanced Study.
The College of Engineering, I think they have the expertise to do this. The Texas A&M Transportation Institute has been developing a reputation in safety for some time. We have the Engineering Experimental Station, so they have the facilities, they have the personnel.
The world heard about the SpaceX Hyperloop pod competition. Over 120 teams of college-age engineers came to Texas A&M to demonstrate their pod prototypes. The 22 winning teams get to build and test their design prototype at the world's first Hyperloop test track, being built by SpaceX in Hawthorne, California. For 17 years, the Texas Engineering Experiment Station's Center for Autonomous Vehicles and Sensor Systems, or CANVAS, has been flying some of the most advanced unmanned devices in the sky. Equipped with various sensors and cameras, even researchers are surprised at the new uses being discovered.
CANVAS brings together people who are experts in autonomy, people who are experts in vehicle dynamics, people who are experts in communications, in electronics, image processing. All of these different areas are brought together so that we can tackle the most important problems facing transportation right now.
To minimize traffic disruption and delay, TTI and the Texas Department of Transportation created a first-of-its-kind 100-mile-long connected work zone on Interstate 35.
We lead the nation in the amount of crashes in work zones. So when we introduce connected and automated transportation, we're looking at how can we bring those numbers down? How can we improve mobility for individuals? How can we reduce the number of crashes across the state and really drive that number down?
This vehicle and this road are engaged in a conversation.
Mooring operation for illumination installation. Right shoulder closed daily until 4 p.m.
It's the newest phase of a chat that began about 6 years ago on I-35 between smart message boards and drivers. Now, the road is talking to a phone.
The application is a prototype for a connected vehicle environment. The type of information that you get would be incidents, slowdowns in traffic, even end-of-queue warning systems.
It stands to reason that Texas A&M's first autonomous car should be a pickup, because Texas. The T's driverless truck is the first ride for students who will design the next generation of autonomous vehicles.
A group of students, under the supervision of one of our faculty, is now transforming that vehicle into a modern automated vehicle.
You're looking at a technology simulation that will cut down on crashes and a glimpse at the future of vehicles and infrastructure speaking the same language.
TTI has a very good understanding of how the infrastructure works, how the devices in the infrastructure works, and what kind of information the infrastructure can provide the vehicles.
What did one car say to the other? Without proper infrastructure, nothing. Texas A&M researchers and students are making sure that autonomous vehicles hear the infrastructure and each other loud and clear.
When it comes to vehicle-to-vehicle communication, we don't necessarily have the flexibility to put antennas wherever we want. So we have to study where are the best locations for antennas.
With all this talk between cars and other cars and trucks and infrastructure, is anyone trying to keep these conversations away from uninvited listeners? How do you store that data? How does it get used?
Big data can be mined for insights into what's happening and insights into the future. In order to mine data, you have to store data. And the storage of data is where people get concerned.
The specific things that we're looking at with respect to interconnected and automated vehicular control and those topics are, we're looking at vulnerability assessments of those systems, those non-traditional systems, those systems that control things in the physical world.
Follow the leader may save lives, energy, and valuable space on our highways. Platooning with cars and trucks is a reality. Texas A&M students and TTI researchers are making it happen.
We are designing, implementing, and testing a vehicle-to-vehicle following system.
We've most recently been involved in the truck platooning project that's been sponsored by the Texas Department of Transportation. We are working with the partner to install equipment and develop the software that will operate the truck platooning technology.
An autonomous vehicle for freight? It's real. It's called the Freight Shuttle. In the prototype stages of development, it will revolutionize the way goods get to market.
The Freight Shuttle system is the first automated system to move freight, specifically designed to overcome bottlenecks on our nation's highways. This allows us to create a time-certain delivery scenario for shippers.
Which came first, the robot or the autonomous vehicle? Texas A&M computer science students are learning from the man who helped build the world's first autonomous motorcycle.
Enabling technologies our department can provide is the deep understanding of the robotics and the artificial intelligence. They will help the autonomous vehicle and the connected vehicle to be smarter, to be safer.
Major events strain traffic management from small city to major metropolis. Texas A&M and TTI developed a solution by cell phone. Yep, there's an app for that, Destination Aggieland.
Our experience with football game day traffic and the Destination Aggieland app has helped us understand how people move around on these big game day events. One of the ways that we think we can improve that experience is with automated connected vehicles, allowing us to handle more pedestrians and more cars in the same general area while still keeping them apart.
With noise, crowds, and confusion, bus drivers need more than two eyes. TTI researchers are evaluating a technology that lends a helping eye, or two, or three.
Mobileye pilot test is an evaluation of collision avoidance systems for buses, and in particular, it's designed to keep pedestrians and bicyclists safe around buses.
That project has been a great way to pilot that technology, get a feel for its advantages and some of its limitations.
What is an autonomous vehicle to do when it can't see lane markings during rain or snow? How about lane markings that talk? A&M researchers have begun that conversation.
One of the things that we've done and we've demonstrated is adding radio frequency identification chips embedded in pavement markings so that the vehicle can still see the pavement marking even in conditions where we can't.
That has been very, very successful with the initial testing we have, and we're looking forward to working with industry and to do some industry-based testing.
How do humans react when their autonomous vehicle does something unexpected? Texas A&M researchers put humans to the test when their vehicle became too autonomous.
Ultimately, what we're looking to do is develop some technology that, as it detects these two different types of errors, human errors and vehicle-based errors, it can then step in and begin to change the experience for the driver or the vehicle to make driving more safe.
One-way roads are supposed to be just that, but wrong-way drivers still bypass current safeguards. TTI researchers are attacking this problem head on, making sure everyone knows there's a wrong-way vehicle ahead.
The system will look at detecting a wrong-way vehicle, notifying the Texas Department of Transportation and law enforcement, and then alerting drivers.
How are our roads going to be shared between autonomous vehicles and non-autonomous vehicles? When the unexpected occurs, who's responsible? These are policy questions TTI specialists are studying.
The questions that policymakers are asking themselves is, how do we protect the public interest, particularly public safety, and how do we leverage these technologies to help us with some significant challenges that we have, but how do we also create a climate where we don't inhibit innovation?
What does the future of autonomous travel look like? What effect will it have on our society and the world? Texas A&M researchers are trying to wrap their arms around hands-off driving.
We look into the impacts of using the technology, what it will do to reduce congestion or improve safety, improve air quality.
You want to see what are the actual effects going to be in the next 10 years so that we can help the cities, the NPOs, the states, the federal government to plan for this.
There is much we don't yet know about the future of transportation, about the role of automation and connectivity, the balance between vehicle and infrastructure. We are in uncharted territory. What we do know is this: what lies ahead won't be like what's come before. We will not meet the challenges of tomorrow using the approaches of yesterday. And we know one more thing. There is no place better equipped, no experts better qualified, and no organization more committed to defining the connected and automated future of transportation than A&M. Come join us in this journey.
There is no other university in the country that can compete with A&M with respect to all the resources that we have.
We have very few limitations in terms of what we are able to do and what we're able to try.
TTI and Texas A&M could be ground zero for the rest of Texas.
The public sector, the private sector need to come together to engage in research that brings the pieces together.
I think when we work together, we'll be able to reduce the period for full automation.
We have a great toolbox opening before us to be able to look into the future and see what these technologies will do.
With new applications, new vehicles, new technology coming online, you're just limited by your imagination as to what you can do.
This is the place to test, develop, pilot these types of technologies. And the only way we're going to really know what the future is really by studying it now.